the talk earlier about Bill Boaz, I got a little story I got to tell. Right here in this hotel, I walk in one day, I'm carrying my bags, I walk up to registration, and before I can even get to registration, Bill Boaz comes right up to me and says, "Can you present?" And I'm like, sure. So I think that was one of the first years that they videotaped. So I get up, and at the time I worked at Lawrence Livermore Labs, so we had like this month-long process to present, to get slides released. So I got up here and I just talked for a half hour. And then as I'm thinking and I'm looking at the previous presentation with all this work that they're doing, kind of the point of what I'm going to talk about is how much work we didn't do. Because one of the goals for Omni-Path Architecture was to support the existing infrastructure that this organization has built up over the years. So it turns out it is possible to support new Fabric features with legacy applications without changing APIs. We can do better. The Linux Foundation did a summit last week, and some of the people who do kernel work were there, and we had a little mini summit, and in that mini summit, it was all agreed that performance is everything. So in HPC, and I think in a lot of industries, but without compatibility, without an application functioning, your performance is zero. So some of the new Fabric features we introduced with Omni-Path Architecture are a per VL MTU, extended MTUs, some new advanced QoS support like preemption, advanced buffering for the VLs, advanced topology support and an extended set of SLs, and extensions to management layer doing 2K MADs, which extends our scalability of our management. So there's three classes of verbs applications. Those that use RDMA CM and query for path records. Those that query for path records but interpret the data in some way. And are all our favorite, those that don't query for path records. And I say our favorite because many of us over the years have tried to figure out how to deal with this situation. So those that use RDMA CM, there's really some subclasses. There's those that query for path records directly, but I don't know of many applications that do that in user space. What I'm really talking about there is a lot of our kernel ULPs, IP over IB, SRP, etc., actually query for path records appropriately, have for a long time. These are the most flexible applications, those that use RDMA CM in user space or those in the kernel. And they're already leveraging the existing infrastructure that exists. So when you get a path record, a lot of the information about the path and about the fabric is given to you. And if you treat that data as opaque and turn around and hand it to the adapter, things work really, really well. The next class is those that query for path records but may interpret the data in some way. The way we've architected Omni-Path Architecture is that most applications in this class work just fine. In fact, I know of only one that had an issue, and it was a very minor fix. So here, caution must be used. Because going forward, the way the verb stack is, which was based on InfiniBand, as we start to see new fabrics come online with new features, how those features map in are going to be less and less in line. And then our favorite, those that just don't query for path records at all. They make assumptions about the fabric, what SLs, what VLs are valid, what MTUs will be valid on a path. Technically, these are not even InfiniBand compliant. As we all know, I don't even know how they would work with Rocky. Rocky needs RDMA CM or something else to sort of do that address resolution. These still work with Omni-Path architecture with those same limitations that they do on InfiniBand. So if you've hard-coded your SL or your MTU in your MPI app, well, it still works with Omni-Path architecture. But still, it's not compliant. So the way we did this is by leveraging the existing verbs fields and emulating an InfiniBand device. So for the per VL MTU, our SL is obtained from the path record, and then those SL to VL details are all taken care of in the driver in the Omni-Path specific code. No core changes. The extended MTU is obtained through the path record, and it's the natural extension of the IBTA values. And again, when that data is treated as opaque, it's passed down, and we handle it in the Omni-Path driver, our specific code. The QoS support in hardware, again, the path record's handed down, we interpret that appropriately, do the right things for the translations from the SL to the thing we call SC, service class, to the VL, put the packets on the wire, and the opposite is done automatically in the driver on the other end. So it's completely opaque. There is one slight limitation, is we are only supporting 16 SLs, even though Omni-Path has the capability for 32. So with verbs, because of the limitations of the existing data structures in the interface, we're only supporting 16, and so far that seems to be a reasonable limitation. For management, a lot of you saw about a year ago when I started posting the changes to the MAD stack. This is where we did change some things in the core. We have two new 2K MADs. This allows for us to do more scalable configuration of the fabric, get more data with each packet. We have things called aggregates, which allow us to actually specify multiple management packets in a single packet on the wire. So the SMP class version, the subnet management packets are very different, and those are for scalability. It's now known we have a 48-port switch, so we've increased the number of ports. The ability to configure that switch takes more packets, and so we wanted to reduce that overhead as much as possible. As a result, some of the management tools that you're used to in InfiniBand no longer work. But then again, applications should no longer require direct access to the fabric. This is one of the things we think going forward we really need to change, is we need to get away from IBNet Discover running as part of your MPI job. There's security issues with that, and for those who don't know, I'm maintainer of the InfiniBand DIX package. I actually help write and modify IBNet Discover. I wrote a lot of those tools. So, you know, it's not that, you know, I'm saying they're wrong. They were the right tool for the time. It was what we had, but now we should move on. We need to have better interfaces, more scalable interfaces in the management. Which leads me to the next thing, is for InfiniBand GSI MADs, we are still supporting those. This allows us to support the CM, the RDMA CM, SA, path record queries, and have full RDMA CM support. But to solve that scalability problem, we've done those modifications to IBACM, for those of you who have been excuse me, paying attention to the mailing list and some of the modifications we've been doing. We have a plugin architecture to IBACM and a plugin for Omni-Path Architecture that does a local SA cache of that data. So job startup and job scalability should be maintained, because you no longer have that single point of failure. And I know that on the InfiniBand side, similar things are being done, and that plugin architecture can be provided for InfiniBand. So moving forward, we would like to see applications stop doing the wrong thing and start querying for their path records, getting that information. This is very important, even on InfiniBand networks that try to support toruses or alternate fabrics. If you don't get that information, your application may fail. So, to summarize, these ULPs work without modification. IP over IB, SRP, ICER, NFS over RDMA, Luster, all the perf test benchmarks, and all the MPIs that we've just used to test verbs. I know there's some other, I think, proprietary things that I've heard of some of our vendors who are using this, and they've reported the same thing. Things are working out of the box. So when I submitted the management changes, there was a little bit of discussion on the mailing list about, what is this 32-bit lid field? And I said, hey, that's for the future. So the future is now. Going forward, we will be working on extending the lid space. Omni-Path Architecture has in the architecture the ability to do a 32-bit lid, which means we can have more nodes on the fabric, larger scalability, better scalability when doing things like LMC, dispersive routing as we call it. So of course the RDMA stack based on InfiniBand only supports a 16-bit lid. So again, we want to support the extended lids on fabrics that require them. So, you know, lots of people make 2,000, 3,000 node clusters, 10 node clusters. Those will work, no problem, just like they do now. But what about the 50,000 node cluster? That's 2,000 more than InfiniBand can support, roughly. And of course, we want minimal to no application changes, because again, without compatibility, your performance is 0. So we're going to leverage the existing addressing schemes that exist to pass the lid data through the verb stack and keep the changes for OPA, again, in the OPA specific code as much as possible. Basically, this is the drawing. An application gets some information, the path record specifies, in the same way Rocky does, use this GRH via the hop limit field. And we like to call that GRD, because there's not going to be a GRH. There's going to be no header associated with that data. It's just global route, quote, data. It passes it down through libIB verbs, libIB UMAD, the verbs core, whatever layers. It hits the driver. The driver looks at that, interprets it, says, I know what to do with this. Strips off that GRD data, uses that data for the correct addressing, puts the OPA local routing header on the packet, sends it to the fabric. And of course, conceptually, the same thing happens on the receive side. We get that LRH in, we interpret that, say, I see that this is an extended lid, I see that this has extended addressing information, I'm going to tack on this GRD, that's going to be passed up to the application. So we're currently in development of this. We already have most applications working with this with minimal or no changes. In fact, the biggest one is some applications needed to be called with alternate input, and this is similar to the way Rocky works and the way they work over Rocky. Some of the standard IBV calls obviously have limitations, specifically the lid and SM lid fields. However, really for SM lid, again, we need to move away from applications requiring that direct management connection. That IBACM and the local SA cache are more scalable, they're better, they're more secure, they can run as root, they don't have, you're not opening yourself up to all those problems. So we really need to move the industry towards that. The SM lid is available via sysfs. For those applications that need it, because obviously the plugins to IBACM, somebody on the node needs to know how to talk to the SM. And then Rocky applications have similar limitations and similar stuff, and we hope to leverage that. So I've already mentioned some of this going forward. One of the big sticking points is, of course, the MTU. The field's IB specific. There was huge discussions a while ago, a couple years ago, about Usenik. And in the end, they kind of gave up, did libfabric. But pretty much every verb's function call and data structure is InfiniBand specific. We now have Usenik, we now have Rocky, Ethernet, iWarp, and Omni-Path Architecture. So with all those different fabric types, it's time to start looking at how we're going to modify that. We were in a talk yesterday about K-Fabric, a similar thing to libfabric. So how can we borrow those ideas that libfabric has done, move them to the kernel? How can we make our application agnostic to things like link layer? And how can we use our applications such that those data structures that we're passing around are opaque when they need to be, and generic. Because we need new interfaces which are not InfiniBand specific. We need interfaces that are fabrics. For management, I ran into this the other day, so I just had to throw it on a slide. OpenSM, libs, the libraries for OpenSM are actually required to install OpenMpi. Why? OpenSM has nothing to do with running MPI. It manages your fabric. So we've kind of, over the years, we've grown this very organically. Things have, oh look, I'll grab this library. These are some of the things that we need to start to separate out and get an actual architecture for the entire stack. Obviously, leverage IBACM and RDMA-CM, as I've said before. I think there's other things we can do in management, enhancing MADs for the RMPPs. There's some other things in the MAD stack I'd like to clean up. So because I've done a lot of work in that area over the years, so it's just kind of near and dear to my heart. And of course, the management interface as well needs to be fabric agnostic. It should be separated from applications, and for those applications that need it, those user space processes rather, SMs, SAs, performance management, SA, getting your topology information for you MPI guys out there, that all needs to be separated out and provided in secure manners, not by going and accessing the fabric directly. One of the things we've done in OPA is by default, only SM nodes can actually access the switches and stuff. So that's a more secure interface. So, why do we have to emulate a verbs device now? Well, I already told you why we have to do it, but, it's kind of frustrating. Why do we have to do this? Because we're not InfiniBand. Usenik, like I said before, gave up, and now they're a libfabric user. So there was a discussion, I think it was yesterday or whatever, made me think, what is a Q-pair? It's a connection, it's an endpoint, everybody has their own name for it. So maybe we change that to be something much more agnostic. What is an address handle? Again, we have multiple fabric types. We need to genericize that address processing. User space has libfabric. What does the kernel have? People have said kfabric. Okay, what do we call it? Kfabric, extended verbs. Does it matter what we call it? I don't think so. What it matters is that we do it. So apps should be agnostic to the fabric, but the interface has to be agnostic first so that they can move to that, and then we can plug these other fabrics in. And as Sean said in a previous presentation with libfabric, because the matrix for libfabrics is exploding, right? Fabrics have this support and that support and blah, blah, blah. But his presentation, he said, here's the easy button. Do this, you're done, you're starting to send data. We need a verbs easy button. Okay, if you want to optimize and do something special on some fabric, great, but you've done that and now that's specific to you. If I go down and I'm writing to the Ethernet layer, I can no longer use sockets if I'm passing packets on the Ethernet layer. There's no way getting around that. People will do it, but for what we're talking about here in this standards body, whatever, that's what we need to do. So here's my legal disclaimers, my optimization notice, and thank you. Any questions? Cool. Oh, sure.
So what you're proposing sounds wonderful. We need an organization that's going to support it, and we need everybody kind of behind it and not splintering and creating possibly some other organization. So what are your hopes that the need for this to stay a standard or come together again, how do we make that happen? Because there's a lot of consternation. I'm sure you all have been hearing it in side conversations. So how do we make that happen? Sorry to put you on the spot.
That's fine, because you're absolutely right. The way we do that is by working together, continuing our discussions. The Linux Foundation mini summit that Christoph put together, wherever Christoph is, thank you, I think is a good start. One of the things that they said was that they have some conference once a quarter. And maybe, we have a new maintainer now. I think the other thing that has happened over the years that I didn't really put in the slides, as we all know, we had a maintainer that was very busy, didn't have a lot of time, and so some of these things kind of sat. And people looked for ways to work around the interface rather than change the interface to make it better. We have a new maintainer now who has more time and I think has a vested interest in making this work for all fabrics for his company. And so I think that we are kind of entering into a new age where we can start to do this type of work. So with the Linux Foundation, if they're doing meetings every quarter instead of this meeting, which is once a year, we could get together and talk about this more face-to-face, more participation on the mailing list, more review of code on the mailing list across companies. So that's what I think we need to do. And I think my management thinks it now too. Anything else? Cool, thanks.